Hello and welcome back to Precalculus. We are going to talk about polynomial division and then remainder and factor theorems. I hope we get to all of that. Now, in this section, we're going to have a long division of polynomials and synthetic division of polynomials. So we're going to see in which way that works and how these theorems fit with all of this, as I said, as we are setting up for that very important section on to 2.5. So where do we start? Well, before I go and do anything with polynomials, let me just divide some numbers here, because the algorithm for division of numbers is exactly the same as the algorithm of division of polynomials. Now, I know that vast majority of students doesn't know how to divide numbers by hand because, right, learned helplessness. We have calculators and things like that, so we don't need to know anything, right? And then when it's time to extend the concept that you don't need to know, all of a sudden, I should have known that, right? So we want to take, let's say, 5,726 and divide that by 13. And we want to do that by hand without using, calculators and so on, which is actually very easy to do. 5,726. And you can ask yourself how many times 13 goes into 57, right? So 13 into 57. Well, the fastest way is to create the multiplication table by adding 13 to itself all the way down. So 13 plus 13 is 26, plus another 13 is 39, plus another 13 is 52, plus another 13 is 65. And you can see that this one ends at 5, which is technically 13 times 5. So it ends at 5, so we're good so far. Like when we get to the 10, it better end in 0. So another 13, that's going to be 78. Another 13 is going to be 91. Another 13 is 104. Another 13 is going to be 117. And another 13 is 130. Aha! That's my 13 times 10. So I know that all of these numbers are good because the last one, right, clicked to be 130. So now I have my multiplication table by 13 by just adding 13 bunch of times. So 57, that's a 52, 1, 2, 3, 4, so it goes 4 times. The number is 52. When I subtract, I get a 5, drop down a 2, and I have 52. Oh, that's 4 again. 4 times 13 is again 52. When you subtract, we get 0, and now you drop 6. 13 into 6 doesn't go, so we'll put a big fat 0 over there. So we have 440 so far. And you still have 06, right? So your option now is to either say remainder 6, which would be R6, and you are done, right? Or you can continue this process by putting a decimal point, adding 0 out of nowhere, put a decimal point up there, continue this process until you bleed under your fingernails, right? Because there is no stopping here. Like a calculator goes, 8 decimal places and it stops. You, with this procedure, can go the entire lifetime if you wanted it to, because you don't have that limitation of, oh, I can only show 8 decimal places or 12 or whatever, right? So you can go forever. But you can also put the R6, meaning the remainder of 6, and you can say that 5,726 divided by 13 is equal to 440, and then the remainder is 6 over 13. Right? That's the way to add this fraction at the end, which is 6 is right remainder, and then it can't divide by 13 anymore. So we're done there. Right? So that's it. So that's division of numbers, and long division of polynomials works exactly the same way. You figure out the value, you multiply that value here and subtract it, and rinse and repeat. right? Drop the next number. In this case, in case of polynomials, you'll see you drop the next term. So to take a look at the division of polynomials, let's divide x plus 2 into 4x cubed minus 6x squared plus 5x plus 10. Okay. All you need to look at to start off are these leading terms for both of the values. And those leading terms, right, are going to be let's see. We have you can do this on a side. 4x cubed divided by x. That's all you're looking for, right? Because you want to know how many times x goes into 4x cubed. Well, that's easy. You just cancel it. It's 4x squared, right? There's no thinking involved in that. You just cancel one x. So that's 4x squared. And now, just like with numbers, you multiply back. So that gives you 4x cubed, and it gives you plus 8x squared. Well, those terms are like terms. They end up on top of each other. And now you subtract. So these guys will cancel. What's left? Minus 6 minus 8 is minus 14x squared. And you can drop all of them, or you can just drop the 5x. Doesn't matter. Because now you can look at this as like a new problem. How many times x goes into negative 14x squared? Do that on a side.
Where did the 8x squared come from?
When I multiply 4x squared by 2. Because I am multiplying back everywhere. Right? This has to multiply both, so it will distribute on both terms. So I get 2 terms. Cool?
Yeah.
Awesome. So now I have negative 14x squared divided by x. Well, that's negative 14x. Awesome. Minus 14x. Multiply back again into both of these. So negative 14x squared minus 28x when you multiply back. And then subtract. What do we get? These guys again cancel. They always have to cancel because you're forcing them to cancel with these values that you're picking over here. So now 5x plus this is 33x, and you have plus 10. Yay! X into 33x. That's 33x divided by x is just 33. So plus 33. When you multiply it back, you get your 33x plus 66. And this needs to subtract. These guys cancel. You get negative 56 as the answer, right? Because it's 10 minus 66 is negative 56. Don't forget subtraction here. Usually that's where the grade dies, not being careful with the signs. And we have a remainder, negative 56. So negative 56 over x plus 2. And that's the answer. The answer is 4x squared minus 14x plus 33 minus 56 over x plus 2. That's it. So now there are subtleties, obviously, so we have to do more examples. But if you're following the pattern, it's absolutely the same as division of numbers. So if you are good with the long division of numbers, technically this is a joke for you. If you don't know how to divide numbers long way, learn that first and be comfortable with that before you try this, because the algorithm is the same. It's just this looks more busy but it's exactly the same as division of numbers by hand. And obviously there are infinite amount of YouTube videos to help with this calculation. Let's take a look at another example for long division before we learn other ways of dividing. So I'm just going to jump into homework here in the book and see some of the examples they're asking us to consider.
Professor, sorry, could you just scroll up just for a second?
Yes.
Okay, thank you.
You are welcome. How about number 15? It looks sufficiently evil. Actually, no. Let's not go immediately with the evil one. We'll do the 15 next. Let's first do 2x minus 1 divided into 4x squared minus 8x plus 6. So this is number 8. So we'll do this one first, then we'll do 15. Now, guys, I am purposely doing homework exercises because the exercises that are done in the book, you can read those, right? And learn from those by reading, and then watch additional exercises that I did, right? Because, I mean, I don't want to do the exercises that are in the book because you can read them, right? You can cut out the middleman of me reading it for you, and then you copy from the screen in your notebook, which is already there in the book to read it, right? So if you're not reading the book, most likely you're not reading the notes, so who cares, right? But if you're planning on reading the notes, then you should also be reading the book, and the book is always going to have better explanation than your notes. I mean, that's given. So you can always find extra examples. Anyway, what do I have here? I have these two puppies. 4x squared divided by 2x, and that cancels down to 2x. So the first one is 2x. It's as simple as that. You look at the leading terms for both, right? And you divide them on a side, and you get 2x. And now you multiply that 2x into both of these. 2x times 2x is 4x squared minus 2x. Subtract them. These guys will cancel. Negative 8x plus 2x is negative 6x. And you drop down plus 6. This is negative x, this negative and this negative make a positive. So you have negative 8x plus 2x is negative 6x. So now you on the side, you have negative 6x divided by, it's okay, tablet, you'll do it, by 2x, because now this is like restarting a new problem. You divide this by that. The same thing like when you do with numbers. And that gives you negative 3 when you cancel the algebra there. So, boom, negative 3. And now, you multiply that negative 3 back into both of these. You get negative 6x plus 3. You subtract them. And 6 minus 3 is 3. Switch it. 3. So your remainder is positive 3, which means plus 3 over 2x minus 1. And you're done. So you always look at the first term, and you divide them on a side. Whatever you get, you put up there, multiply it back, subtract, drop the next term, rinse and repeat as long as you need to be done, right? Until you're done with the whole thing.
So the first term of like every new next line gets dropped?
It doesn't get dropped. When it subtracts, it goes away, because remember, you got it by division, and when you multiply back, you get the same term back. So when you subtract them, they cancel. It's not dropping out of nowhere. 4x squared minus 4x squared is 0. And you got it to be 4x squared because you fixed it to be 4x squared.
Yeah, that's what I meant to say. I don't know why I said drop, but that's what I meant. It gets canceled.
Yes, because you divide it to get the value, and then when you multiply the same value, you'll get the same term back. And that's why they're always the same and they always cancel.
Okay, thank you.
You're welcome. Let's take a look at another one. Now let's see this 15 I mentioned before, which I skipped. They say 18x to the 4 plus 9x cubed plus 3x squared divided by 3x squared plus 1. So this is the way they phrase the question. We all know that the fraction is just division. And there are some problems. See, there is a linear term missing here, right? There is no x term. It's just x squared and then a constant. So when you have something like that missing, you should put in what we call a placeholder term, which would be 0x. We don't have to add these because they're at the end, so we don't have to care about them. But when they are missing in the middle, right here, I need to say plus 0x. I mean, I don't need to, but it makes lining up these terms later on much easier. Now you'll understand what it means when I start doing the division here. So I'll have 3x squared plus 0x plus 1. See, my placeholder is in. And I have 18x to the 4th plus 9x cubed plus 3x squared. You can go on plus 0x plus 0. You don't have to because they're at the end. It's just bad when there is a power. So if these powers were 4, 2, 1, I would put in 0x cubed in between, right? So I would complete, so I have all of the powers. As I said, you don't have to do it when the end is missing. So now let's see. I have 18x to the 4 divided by 3x squared. 18 divided by 3 is 6, and then this is x squared. So 6x squared. And now when you multiply it back, you're multiplying into all three of these. See, you get your 18x to the 4th back when you multiply. And then you get your plus 0x cubed, because 0 times 6 is 0. And x times x squared is x cubed. And see how it lines up under x cubed. And then you have plus 6x squared. If you without this one, right, you would just have this term and this term to write, and if you don't line it up, you might miss the addition. You would just say, oh, not like terms, but it can add here. So you have to be careful, right, a little bit with the lining up these terms. And now we subtract. The first term will cancel because 18 minus 18, right? And over here you have 9 minus 0, that's 9x cubed. And now you have minus 3x squared, because 3 minus 6 is negative 3. So now you go on the side and you say 9x cubed divided by 3x squared. Well, 9 divided by 3 is 3, and then a single x, right, when it cancels, survives. So plus 3x on top. And what I do with it now is I do the multiplication, right? I multiply back. I get 9x cubed plus 0x squared and plus 3x. So that 0x could be useful here, but it's kind of at the end, so you know it's a 0 above. It's not as bad as the other ones when they're missing in the middle. Subtract everything, the first ones cancel. And you have your minus 3 minus 0 is minus 3x squared. And then you have 0 minus 3 minus 3x, right? Because there is a plus 0x on this, which we didn't write. So 0 minus 3 is negative 3x. So whether you have this 0x or not, doesn't matter. Well, the only thing that it's left is for me to go within these. That's negative 3x squared divided by 3x squared, which is negative 1. So, negative 1. And we multiply back. It's going to be negative 3x squared plus, again, 0x, and then minus 1. And once we subtract, we'll have the remainder. Sometimes it divides evenly, no remainder. But in cases we had so far, they all had the remainder. So that's negative 3x plus 1, right? Because negative 3x plus 0x is just still negative 3x. And then you have this 0 here, minus minus 1, right? This is a negative here and the negative there. Negative and negative is a positive, so it's a plus 1. And that's why we have a plus 1 on the bottom. So we would say plus, and then you have your negative 3x plus 1 divided by 3x squared plus 1. You don't have to include that 0x in the answer. And there's the answer. So it's going to take some time to practice this, but it's doable. Meditate on this. Should we do another example?
Yes, please.
I can feel the pain in the voice.
Sorry.
I mean, I can't fix that. I can just assign another exercise. You have to come to terms with this. 16, 2x to the 5 minus 8x to the 4 plus 2x cubed plus x squared divided by 2x cubed plus 1. So try to set it up and go a few steps. I'm going to go switch my ice pack for the last 20 minutes of the 25 minutes of the class. Aha, the new ice pack is in. So I hope you picked up already that you have two of the placeholders, right? 0x squared plus 0x to put in, and then go from there. So I hope you have those. I'm going to give you some more time to grind through this. "18 seconds left." Let's take a look at this division together so we can move on to actually stuff that we're supposed to learn. This is supposed to be clear from intermediate algebra, but I know that it gets lost in translation because of the inability to divide basic numbers, right? So then this becomes something that looks weird and hard, which in fact is the same thing. So when you learn the numbers, this should immediately click. All right. 2x to the 5 divided by 2x cubed is just simply x squared. X squared. Multiply back in all four. 2x to the 5 plus 0x to the 4 plus 0x cubed plus x squared. Subtract. The first term drops. Minus 8 minus 0 minus 8 x to the 4th. Plus 2x cubed, right, because you're subtracting 0 again. And now x squared minus x squared, that drops as well. So this is the only thing you're left with. So now, negative 8x to the 4th divided by 2x cubed. Well, that's minus 4x, right? Because negative 8 divided by 2 is negative 4. And then when you cancel the powers here, you just get 1x. Multiply it back. Negative 8x to the 4 minus 0x cubed plus 0x squared and minus 4x. So we subtract, the first term will again drop. So now I have 2x cubed because that's a 0. That's not going to do anything. We still have plus 0x squared over here and minus 4x. All right, so now 2x cubed divided by 2x cubed. Those are my front coefficients, leading terms. So that's a 1, plus 1. And you multiply it back. It's 2x cubed plus 0x squared plus 0x plus 1. Subtract. The first one will drop. And we get 0x squared. I don't need to write it. I get negative 4x minus 1. Again, there's a minus in front. This is a plus 1, so that becomes a negative 1. So, plus negative 4x minus 1 over 2x cubed plus 1. Now, you can flex a little bit and factor out that minus sign. Because they both have minus, you can factor that minus and put it down. So if you have your x squared, what was it? Minus 4x plus 1. Plus negative 4x minus 1 over 2x cubed plus 1. You can factor this negative on top. So x squared minus 4x plus 1 plus, and, oh, actually no, minus because you factor it, and it becomes 4x plus 1 over 2x cubed plus 1. That's the algebraic flex that we like and respect, right? But it's not a part of the division, right? It's part of presenting your answer. Your division is given right there. Good. So this is division of polynomials, and we are primarily interested in division by a linear term, because we're going to see, we know already that our factors are all linear term, like that x minus 2 and x plus 1 and x plus 6, right? The ones that you set equal to 0. So we are primarily interested in division by those terms, linear terms, and there is a very easy way to divide polynomials, like a pattern with numbers, without writing all of this stuff and going through these polynomials. But it works only for division by linear terms. It will not work for this problem or any problem we did so far, right? Yep, wouldn't work there. That's not linear. It would work on problem 8 with some modifications. It would work on problem 8, and it would work on this problem as well, right? So it would work on the linear terms, but anywhere you have more than x, right? You have x squared, x cubed to divide by, it's not going to work. So we're going to learn this method, and it's called the method of synthetic division. Can you live without this? Yeah, just use the regular division. Yeah, not a problem, right? Use the long division 100% of the time. It's just that this particular method is really fast, and it has a pattern, and you don't have to go through like writing 5,000 things. So, guys, and this is a procedure, so you have to pick up this procedure while the problems are done. There are no theorems or definitions or anything like that. It's just there is a procedure. and you go and you solve a problem. So let's pick on a problem and do it. How about actually we solve that problem we had, the first problem we had? It has large numbers, which doesn't matter actually. I'm going to copy this and then delete the answers and stuff that goes. I just want a problem. Synthetic division. It's going to be weird, but you'll get through it. So this is the way the problem is asked, or it can be asked as a fraction, right? Of 4x cubed minus 6x squared plus 5x plus 10 divided by x plus 2. For synthetic division, you have to divide by the linear term. Let me write that in blood up there. Must divide by a linear term. There we go. Now, the setup. No matter what you're given, you will use -2 in this box because that's a +2. -2 is the root, right? Remember when you set x plus 2 equal to 0, you will get x equals -2. That's the -2 that gets stuffed in. Some students like to memorize, always use opposite sign. Yeah, that works too. But it's better if you know what you are actually using, not just the opposite sign, so it works, but it's actually the root that you are stuffing into this thing, as we are going to see later on. And all you need to do now is to pick up your coefficients. 4, -6, 5, and 10. So you space them out a little bit. That's your setup. So you'll always use the root, and you can always get the root when you take that bottom and set it equal to 0. So use the root in the box on the side, and then just pick up the coefficients with their signs. If there are negatives, right, that has to go with. So that's the setup. Coefficients. All right, so let's now take a look at the procedure, and you will see that this thing just flies. So here is the procedure. You drop the first number down as is. You just drop it. By the way, this is your answer line already, so it tells you that this is really short, right? You drop your answer down. Then you multiply that answer with a root and just add. You multiply the answer with the root and write it here. That's positive 28. And add. And you multiply your answer again and add. Now, you need to write your answer. See, the last one is the remainder. So if you started with x cubed, then the first answer is x squared, always one power down because you were dividing by x. So you're dropping down by power. So if the input is x cubed, the output over here is x squared. So you have 4x squared minus 14x plus 33 minus 56 over x plus 2. That's all it took. 30 seconds. Instead of all of this. Right? Synthetic division is insanely fast when you know the procedure, when you learn, right, the pattern, because it's a pattern which you memorize. There's no going around it. I'm going to do another example, and this example I'm going to work out side by side, by hand, and then by synthetic division, so you can see both of them worked out. So x minus 1 divided into 4x cubed minus 3x squared plus 3x minus 1. I'm going to go quickly to this because the synthetic division is the point over here. Okay, so x into 4x goes 4x squared, multiply it back, 4x cubed minus 4x squared. When I subtract these die, minus and plus, so it's a single x squared, drop these guys. X goes into this plus x, goes x squared minus x, again subtract, gone, that's a plus, so it's a 4x minus 1. X into 4x goes plus 4 times, multiplied 4x, minus 4, subtract, gone, that's a plus 4 minus 1 is 3, so remainder is plus 3 over x minus 1. So it takes time, and it is annoying, right? But now let's take a look at the synthetic division. That's a 1, because it's opposite sign, or so say a root. And then you go, oh, my coefficients, 4, negative 3, positive 3, negative 1. 4, negative 3, positive 3, negative 1. Those are the coefficients. All right. Drop the first one. Then 4 times 1, 4 times 1, and you write the answer there, 4. You add them, you get 1. Then 1 times 1 is 1. You write it there under positive 3, right? 1 times 1 is 1. You add them together, you get 4. 4 times 1, put it in here, you get a 3, and that's the remainder. Box it off that way. If this started as x cubed, then this one starts as x squared. So 4x squared plus 1x plus 4 plus 3 over x minus 1. Hey, that's exactly what we have over there, except we are able to do it in 30 seconds rather than going crazy with all of the calculations. Another one. This is your problem 29. It says, yeah, we're going to end today with this synthetic division, and then we'll deal with the theorems next class. X minus 4. All right, so immediately we say 4. Now this is the x fourth coefficient, right? 1, x cubed is 0, x squared is 0, single linear x is 0, and finally negative 256 at the end. You got to put all of these placeholders here, right, and get your constant at the end. So x to the fourth, and then all of the missing ones, and then go. Drop down the first one, multiply, put that in, add, boom, multiply, add, multiply, add, because 0 plus 64 is 64. Multiply, add. Ooh, we divided evenly. Nice. And since we started with x to the 4, the answer started with x cubed. and no remainder. So just plus 64 and you're done. Wait, it divided evenly? Yeah, using algebra, you can break this into x squared minus 16 and x squared plus 16, right, using basic algebra. And then you have your x minus 4, x plus 4, and the x squared plus 16 cannot factor over real numbers. And look, the denominator completely cancels because one of the factors is x minus 4. So technically, if you are to multiply this, you'll get that. So synthetic division is insanely fast, but the limitation is that over here, you can only have x plus minus c. You are limited. You're limited to that. And it makes a problem if it's like, let's say 2x plus 3. Right? Then good luck, right? Because your x is equal to negative 3 halves. Well, guess what goes in a box, right? Negative 3 halves. So then you have to drag your fractions through calculation. I mean, it's still going to be easier than and faster than the long division, but you have to drag the fractions through it. So, you know, such is life. So synthetic division is designed, right, to plow through these calculations, and you will have to do it so much in 2.5 that it's really worth a while spending a long time figuring out synthetic division, going through examples and practicing. Now, obviously, we're not done with this section, so we'll practice this more as we do the two theorems which use this synthetic division. So there will be much more added to this lecture in terms of examples. But I hope that synthetic division is sold to you, and it will be used heavily in 2.5. And then later on, anytime you need to divide polynomials, I mean, if they are divided by the linear factor, you can quickly use the synthetic division.
Is this only if you're dividing by an x with no exponent?
What do you mean dividing by? I'm not understanding the question.
Because you're doing these examples with like x minus 1 or x minus 4, but
Yeah,
no,
that's
like
what the linear
x...
exponent is 1. It's a linear, right? So x to the first power, which is yeah, the linear. Yep.
Okay.
So it doesn't work for square, it doesn't work for cube. If you're dividing by any of those, you have to use the long division, and good luck.
Got it.
That's what I said. The limitation is that you have to use it only for the linear terms. And that's the end of the story. All right. Well, that's it for tonight then. We'll be back in 2 days, and we'll finish this and go into 2.5, see what it brings. Coming up by the end of the next week, we'll be done with the chapters and ready for the first exam. So stay tuned, right? Bye.